Ready? Good morning, folks. We're going to be doing a GPS video for the class for the upcoming week, the first week online. This is RTK GPS. This is one of the most useful ways that the systems are used in construction, on job sites, in all types of formats, machine control, as well as just general surveying. Real-time kinematic is we're connected to the internet via this tablet computer, communicating with the GPS, which is communicating with the satellites, giving us a position on the ground to the tip that is within about 1/10 of a foot. What we're going to do is, the first thing we're going to do is we'll go into the monitor sky plot, and as you can see, we're calling this job video 1. With the monitor sky plot, it's going to give us the ability to show that we've got a fixed position and we've got an elevation here in the area of Mississippi that we're working of 9.9 feet. You can see it is varying. We can take a look at what we have as far as a sat view, and it'll show us the general grouping of satellites. This being a north position, and north actually being in this direction, we can see that we got a grouping of satellites with GPS as well as the GLONASS systems. If we go over here, we can look at the sat info. It's telling us the number of the satellite, the position in the sky, and which elevation it is in reference to the horizon. If we go over to reference, this is telling us that we're talking to a virtual base that is showing that it is close to us. But what's happening is this system is taking its position and it's taking a virtual position and then giving us the fixed position. It's the same way that your phone works when you're trying to find a gas station, a pizza place, or even for that matter, Tiger Stadium. So we're going to go back in and we're going to show you how we set it up. We're going to set up a job. First thing we did was we said, okay, this job, we're going to call it GPS Video 1. We accept that job. Then from there, we went into equipment and we set up a GPS rover. Now we're going to go through this and show you how it's set up and go through the whole mechanics, but you can see we've got the instrument type. It's a Sakia GRX3, and we're telling it to connect. It's going in and it's connecting back into the system. When it comes back, it's going to tell us that it's got successful connection. We go to monitor sky plot, and some of the things we looked at before, it's showing us float. It's going to go from float to fixed, and you can see that the signal latency is almost immediate. In other words, the system is talking to us at a crisp rate, which gives us the ability to come back in here and see that we're at a 9.6 feet. Now, this might vary a little bit because the point is actually down in the shell, so we're going to be shooting to the tops of 4 hubs. And when we shoot to the tops of the 4 hubs, we're going to be getting a local elevation that is relative to that. We're going to hold the position 1 as our base position, but we'll go back to the main screen. We're going to tell it survey. We're going to store points. And what we're going to do is we're going to tell it point number 1. We're going to give it a denoted information note. We're going to call it a control point CP. As you can see, right now it's showing us that we've got a red on the top, and that red is relative to some of these numbers that are varying down here. When this goes above 0.1, the red comes back. You can see the 0.1. When we get away from the house and some of the trees, we're going to be in a fixed position to where we can get good data. Now this is going to go fairly rapidly because of some of the things to keep video in a format so we can get this to you. So we're going to take this out of its stand, and then we're going to proceed to get point number 1. We're on the top of the first hub, and as we were talking about in class, it's critical to hold the prism pole in a plumb position, and we do have a vial to allow us to hold plumb. So right now what it's doing is it's going in and out, and that's probably got something to do with the constellation or the positions of the satellites. We're talking to 14 satellites out of a total of 22, and at this point you can see our numbers are running not as crisp as what they can sometimes, but that's got a lot to do with possibly just the GPS position. We told it that we're working at 2 meters. From the base of the point to the top of the antenna is 6.52 feet, 62 feet. So we're here. This is about the best numbers we're going to get. We're holding it plumb. We don't want to hold it rocking it back and forth. We want to hold it plumb, steady. And what we're going to do is we're going to tell it, okay, store. These are a group of informational things that allow you to either say, yes, this is good, or no, it's not, I want to recollect it. We're going to take and accept that. We hit the check mark. It increments to 0.2. 0.2 is going to be a control point, and we're going to go to the next position. There again, we're holding the pole plumb. We're taking, the numbers are holding pretty tight at about that 0.08, which tells us we're within about 1/10, and you can see it's actually coming down a little bit. But because of some of the environment that we're in right now, we're going to hold it plumb, hit S for store. We've got a series of information. You can see that number came down for the horizontal from 0.8 to about 0.6, just about a couple of hundredths. So we're talking not a whole lot. We're going to accept it. We're still talking to 16 satellites. We're going to proceed to 0.3 and collect the third point. Right now you can see it's in a fixed position and there's a red screen. That's got a lot to do, I guess, with some of the positions on the satellites, but honestly right now we're talking to 18 satellites, which is terrific. But we've got a position of 0.7, which was the last one was 0.06. So number of satellites does help, but not necessarily give us the best of positions. At this point, we're calling it 0.3. We're calling it a control point. We're going to hold the pole plumb. When the pole is plumb, we're going to hit the S for store. There again, a group of data, looks good. 0.08, that's the same as about what we had for position 1 as far as that confidence number is concerned. We accept it. It increments to point number 4, control point. We're going to go to our last position. And we're shooting the tops of the hubs, getting the elevations, which we said was 2 meters from the base of the antenna to the top of that hub. Lots of times on job sites, you got to put in temporary positions like this to be used with lasers and levels. So right now what we're going to do is we're going to get this last position. We're talking to 18 satellites again. At this point, we're going to hit store. There again, we've got pretty decent information. We hit the check mark and we hit store. And if we go out of this, we can go out, go back to file. Go to points, and you can see that our elevations on the tops of the hubs, point number 1 was 9.8, sensitive. Point number 4 was 9.195. So the difference between the two is about, what is that, 6.33 as far as 0.633 from top of one hub to the other. So 4 is lower about a little bit more than a half a foot. Now at this point, as you can see where we are, we're in the middle of a field, an area that we're going to use for a laser demo as well. These 4 hubs that we shot to, we're going to set the laser level up on another video next, and what we're going to do is we're going to hold point 1 to 100 feet. So we can use this first video with the GPS and track it into the second video with the laser level to show you how it's actually done on a job site. And Lab 9 has basically that feature of comparing relative elevations. Thank you for listening to this. All suggestions would be very welcome.